Okay, so we are going to see today a question from operating system which is on 1 mark. It had appeared in GATE 2013 and the topic is CPU scheduling algorithms. Now the question reads that a scheduling algorithm assigns priority proportional to the waiting time of the process. So let's note down this important point here. The priority of a process is directly proportional to the waiting time of the process. Okay, waiting time of the process. Now every process every process starts with priority 0, which is the lowest priority. So let's make note of that. 0 is equal to the lowest priority. So we are noting down the important points from the question so that we can use it while solving the question. Now the scheduler re-evaluates the process priorities every t time units and decides the next process to schedule. So let's make a note of here. Every t units of time, priority is let's say priority is decided. After every t units of time, priority is calculated. Now, which one of the following is true if the processes have no IO operations and all arrive at time 0? So all the processes arrive at time 0 and there are no IO operations. And option A reads the algorithm is equivalent to FCFS, this algorithm is equivalent to round robin, this algorithm is equivalent to SJF, shortest of first, and this algorithm is equivalent to shortest remaining time first algorithm. So what we are going to do now is we are going to take an example and try to run this algorithm. Okay, so let's assume we have three processes, P1, P2, P3. Okay, and initially the priority of all of them is 0, 0, 0, 0. Okay, as given in the question. Let me point it out. Here it is. Yes, every process starts with priority 0, which is the lowest priority. Okay, now let's come here. Let's have our CPU here. Let's say this is our CPU. Okay, now what is going to happen is initially when the ready queue starts, we are going to have when the ready queue starts, we are going to have P1, which will get assigned to the CPU. So P1 will come to CPU. It will spend time 0 to 3 seconds with the CPU. Okay, I missed one point. We are going to assume let t be equal to 3. For this example, let t be equal to 3. So after every 3 units, the priority will be rescheduled or re-evaluated. Let me even strike that out. Let me strike this out. So priority is going to be re-evaluated. Okay. Yes. So when P1 is picked up, P1 will spend 0 to 3 seconds with the CPU. Now while P1 is spending that time, the waiting time of other processes is increasing. So P2 will be waiting for 3 seconds, P3 will be waiting for 3 seconds, while P1 is with the CPU. Now, after every 3 units of time, we are going to re-evaluate the priority, and the way we are going to re-evaluate is this. We are going to use this equation, which says priority is directly proportional to the waiting time. So hence, the priority is going to change, and we are going to make this priority proportional to the waiting time. So this will be 3. This priority will be proportional to its waiting time, so it will be 3. And now, when we look at this priority column, we see that we have higher priority processes than P1. So P1 is going to get striked out, it will come out of the CPU, and P2 is going to get selected here. Now again, P2 will spend next 3 seconds with the CPU, so it will be 4 to 6. And while P2 is spending time with CPU, the waiting time of P1 and P3 is increasing. So P1's waiting time will now be 3 seconds and P3 will be 6 seconds. Now, after every 3 seconds, okay, priority will be re-evaluated. So we are going to re-evaluate the priority using this equation. It is directly proportional to waiting time. So what is the waiting time here now? The waiting time is 6, so this will become 6. The waiting time is 3 because P2 is with CPU, so this will remain 3 only. And here the waiting time is 3, so this will now become 3. And after every 3 seconds, again we are going to look at this priority column and we are going to check which one to pick up next. So as you can clearly see, P3 is the highest, so P3 will be selected and it is going to spend next 3 seconds with the CPU. So 7 to 9. Note, 0 is the lowest priority. Okay, so 6 becomes the highest priority. So P3 spends next 3 seconds with the CPU. Now again, while P3 is spending next 3 seconds with the CPU, the waiting time of P1 and P2 is increasing. So let's recalculate the waiting time. The waiting time of them will be now 6. This will be also 6. And after P3, after 3 seconds have spent with the CPU, we are again going to re-evaluate the priority. Re-evaluate this priority using priority is directly proportional to waiting time. And thus, finally, we are going to change this priority to this 6. This priority to this 6. And priority of P3 will not change because it is already 6. Now, if you carefully observe, let me highlight it for you. If you carefully observe this priorities 666, it is exactly equivalent to the initial priority 000. Whatever we started with 000, we are again back to that 666. Thus, what is going to happen in the next iteration is same. P1 is going to get selected, then again the waiting time of P2 and P3 will increase, their priority will change, then P2 will get selected, then P3 will get selected. Which means in the next iteration also, we are going to have P1, P2, P3, okay, with the time quantum of 3 seconds. So this will be 10 to 12, this will be 13 to 15, I should have planned it better, this should be 16 to 18, okay. Thus, we can clearly see that P1, P2, P3, they are running in this same order for 3 units of time. We randomly assume T. For T units of time, P1, P2, P3 and P1, P2, P3 are getting scheduled with the CPU. So this is nothing but round robin. Okay. For a fixed time quantum, every process runs with the CPU. Thus, if we come back to the question, if we come back to this options A, B, C, D, we can clearly see that option B, okay, which says the round robin algorithm. So this algorithm is equivalent to the round robin algorithm.